Okay, so for the second class of this forces and equilibrium, we are going to do now equilibrium. And this is, I think, more easier than the previous one as well. You will see. It's very much related to the same forces. Now we have understood how to break down into components. Break down any force into its horizontal and vertical components. We have understood this. And we also know that the resultant force, and we also know the angle, how to find the angle, and the formula for the theta, and with reference, we have to find the angle with reference. So these are one of the types of questions that come in the exam. The simple finding the resultant force and the angle that it makes. And the next thing that comes in force in equilibrium, forces in equilibrium is equilibrium. Equilibrium means that anyone can explain equilibrium. What do you mean? In O level physics or IGCSEs, you have done equilibrium. Anyone has any idea what is equilibrium?
When forward force is equal to backward force.
That is one of the definitions, but this is slightly, what do you say, incomplete.
Oh,
Not
when
just the
resultant force is equal to
yeah,
0.
yes, that's it. Whenever they talk about equilibrium, your resultant force is always equals to 0. And there's one more thing also. There's I think this you do in your AS level physics, that for complete equilibrium, your resultant force on an object or on a point should be 0, and the sum of moments also across on a on the object should be equal to 0. Right now we are going to work on this part. Okay, this is right now of more concern right now because this force in equilibrium. So you would be, they would tell us that the point is at equilibrium, or the object is at equilibrium, or the car is at equilibrium, and then they will ask you to find the unknown values. So using this definition for equilibrium, that the resultant force would be equal to 0, this would mean that the sum of horizontal forces would also be equal to 0, and the sum of vertical forces would also be equal to 0. And then if you use this 0 squared plus 0 squared as under root, that would give you the resultant force of 0. So horizontal component sum and vertical component sum would also be equal to 0 if they tell you that the system is in equilibrium. One more thing that we can now, to make our lives easier, we can say the for the horizontal components to be equal to 0, the left word, what do we say, the left word components, the negative, what do we say, the left word forces would exactly be equal to the right word forces. Right word, is that a word or not? Forward होता है, right word, backward, ऐसे होता है. Right words forces, I don't know if this word is correct. Left word होता है left word. Okay, so the left word forces and the right word forces would equal them, would equal each other out, so that the sum of the horizontal forces would be equal to 0. Now this is something that we would be using. And one more thing from the vertical components is the upward forces would be equaling out the downward forces. Now this condition will help you to find the unknown forces. You will see how right now. This is, you would apply this condition whenever they talk about equilibrium. So let's suppose they've given you a situation. This is 10 Newton. This is I don't know, 13 Newton, and there's another force like this. Suppose this is F Newton. You don't know. This is, let's suppose this is 50 degrees, and this is 70 degrees. Now they are telling you that this system is in equilibrium. When you see this word equilibrium, then this should click your mind that the sum of forces would be equal to 0. The sum of horizontal forces would be 0 and the sum of vertical forces would be 0. So what do you do in this case? Let me resize it, make it larger. Okay, now what do? You use this condition. You will use this condition. So first of all, you break down your forces again into the components, the relevant components. So the vertical component for this thing, and the horizontal would be this, and horizontal would be this, and vertical would be this. So this would be F, and the component opposite to the angle is sine, F sine 70. Okay, and this one would be F cos 70. This component would be 13 cos 50, and this would be 13 sine 50. So you broke down all your forces into the components. Okay, the question is find F. Okay, find F. So what do? You know that this system is in equilibrium. So sum of vertical force would be equal to 0. So the vertically upward forces would be cancelling out the vertically downward forces. So upward forces, there's only one, which is F sine 70. And this would be equaling the total downward forces, which is only how much? Which is right now this 13.5. No, sorry, okay. 13 sine 50. So in this one, you don't need to be, what do you say, vigilant about the sine thing, because you are equating the leftward forces on the rightward forces. So you don't need to worry about the sine thing, the sine convention over here, because they are cancelling each other out. The sum would be equal to 0. So now if you solve this further, you will get your final answer for F, which would be 13 sine 50 upon sine 70, which would give you your F. How much is it? How much would that be? Or a better, I think the question is right now not a very great one. Let me correct this question. Let this also be unknown theta. You don't know this theta. Find F and theta. So this would be F sine theta, F cos theta. So this would also be sine theta, and this is the first equation that you get. Most of the time the question would be something like this. This is a more better question. There are two unknowns. So you form an equation from the sum of the vertical forces. Now you'll find another equation from the sum of horizontal forces. So horizontally rightward forces, there's only one, 10, would be equal to the horizontally left one forces, which is F cos theta and 13 cos 50. Now you have to simplify this, get the answer for F and theta. Now this is simplification, the simultaneous equation. So 10 minus 13 cos 50 is equals to F cos theta. This is your equation number 1. And when you simplify this thing, 10 minus 13 cos 50, this would be 1.643. 1.644 equals to F cos theta. Now this is your another equation. Another way of solving this equation simultaneously is dividing the two equations. So this would become F sine theta is equals to 13 sine 50, and the other is F cos theta is equals to 1.644. You divide both equations together. So the F and F would cancel out, and sine theta upon cos theta would be tan theta. So tan theta would be equal to 13 sine 50 upon 1.644. You find the theta value like this now. Tan inverse of 13 sine 50 upon 1.644, which is 80. 80.63 degrees. And now you want to find the value of f. You can substitute it in any of the other equations. So f sine 80.63 is equals to 13 sine 50. So now you can find your f value as well from here. So 13 sine 50 upon sine 80.63. So you're getting 10.09 Newton. This is how you would do. This is a very past paper like question. So the concept is very, very simple. I don't think so. This is a very hard thing to understand. But if you have any questions, ask. Okay. So what are we doing? We just know that the system is in equilibrium. So we are equating. We are forming an equation for the sum of vertical and the horizontal forces as 0, because it is at equilibrium. There is no resultant force. Okay. And this is one of the other ways. This is another way of solving simultaneous equation. If you have any question, dividing the equations, another way of solving simultaneous equation. Okay, we are moving on to a past paper question, an application. Now the question would be given. Look over here. Look, these are equilibrium questions. From question number 1 till 9, show that question number 1 till 9 shows a particle is in equilibrium. And then they are asking you to find the unknown thetas, unknown angles, and so you can try these if you want to. Otherwise, we have a lot of past papers on this as well. So it's better that we move on to the past papers. Like these are all practice questions. Do the past papers? They are more important. Let's see. Resultant force. No. No, not this one. We did this one. Resultant force. Okay. Okay, so they have given you a particle P is an equilibrium on a smooth horizontal table under the action of horizontal forces of magnitudes F, G, and 12. Okay, so F and F, both of these are same in magnitude, and G, and this is 12. Find the values of the of G and F. So again, the thing is we would break them down into the relevant components. So this one would be the horizontal component of this F, this one, which would be F and then cos 20, because this component is with the angle, adjacent to the angle, and this one would be F sine 20, and for this one it would be like this, which would be F cos 50, and this would be F sine 50. There is no other, I think, a slant tilted force. So what do? They have told us that the system is in equilibrium. So vertically upward would be equal to vertically downward. So vertically upward, there is only one, which is F sine 50 is equal to vertically downward, you have 12 and you have F sine 20. You will use this and you can easily find the value of F, right? So this would become F taken common, sine 50 minus sine 20 is equals to 12. So this thing would go on the other side and divide. So F would be equal to 12 upon sine 50 minus sine 20. So 12 upon sine 50 minus sine 20. So you're getting 28.3. This is simple. Newton. You got your F. Now for the horizontal ones, you will form another equation. So to the right side, you just have one force, which is F, and to the left side, you have two forces, F cos 20 as well as F cos 50. Now you have the value of F, which is 28.3. Look, so you can use this value multiplied by cos 20 plus cos 50. So I took this F common out. Okay, so you're getting this value of G, which is equals to 44.78. That's it. This is your final answer. Easy, 6 marks. Any questions? Murtaza, Nuba, Nadia.
No, sir.
Asan, easy.
Yes.
It's not that hard. You just need more practice. If you don't do the silly mistakes in breaking down into the correct components, and don't do this plus minus mistake, otherwise this there is nothing. I don't think so. There's any complicated thing over here. Let's see if we have a very complicated, difficult question. This is also the resultant force. Resultant force. This one I've solved over here. Wait a minute. Okay, let's do this one. The second part is more, I think, interesting. The first part is again very repetitive. The next thing we'll do is find a past paper question from a very relevant, very recent past papers. Do your work neatly, properly, and you will get the right answer always. So what do? First step always is to break down into the correct components. So this one would be F. This is with the angle, so this would be F cos theta, and this is vertically upward, so F sin theta. This one would be 12 cos 30, and this would be 12 sin 30. Find the values of F and theta. So now you form your equations. The condition is that the sum of vertical forces is 0. So vertically upwards, you just have two forces, which is F sin theta plus 12 sin 30. It is equals to 10 vertically downward force. So F sin theta would be equal to 12 sin 30 would be 6. Sin 30 is half. So half times 12 is 6. So 10 minus 6 is 4. Now you form the other equation. So to the right side, you just have F cos theta. And on the left side, you have 12 cos 30. So this is your first equation. This is your second equation. You have both of them. You divide both the equations. This is another way I told you. So this was when you divide these, the F and F would cancel out. Yeah, 1 minute ago. This was F theta. Sorry. This was F sin theta. When you divide both of them, so F and F would cancel out, and sin theta upon cos theta, it would be 4 upon 12 cos 30. So tan theta would be equal to 4 upon 12 cos 30. So theta would be easily found out. Tan inverse of 4 upon 12 cos 30. So tan inverse 4 upon 12 cos 30, which is equals to 21.05 theta. And now you can use this. So F sine 21.05 is equals to 4. And now you can find your value of F. 4 divided by this answer. This is your final answer. 4 divided by sine of this answer, which is 2 under root 31, which is 11.14 Newton. That's your final answer. Okay, you found your F, you found your theta. Form the equation properly and then solve them simultaneously. State the magnitude and direction of the resultant force at P when the force of 12 Newton is removed. State the magnitude and the direction of the resultant force at P. So if this 10 force is removed, we have to find the magnitude and direction of this, what do we say, क्या कहते हैं इसको, resultant force. So it's the same old thing. Anyone बताओ मुझे.
Sir, is it 10 Newton or 12 Newton?
Is it क्या?
Is the 10 Newton being removed or 12 Newton being removed?
10 Newton is being removed. Sorry, एक minute. State the magnitude and direction of the resultant force when the force of 12 Newton. Sorry यार, my mistake. अगर 12 Newton, this force is removed. Sorry, I read it wrong. What would be the, this is written state. This means that you have to use your logic and you don't need calculation over here. Anyone who can use logic, whose physics is good and concept of this force is good, let's see, think about it. You don't need calculation. Look, you can do the calculation. They have not forced you not to use the calculator, the calculations, the formulas and everything, but this is written state. State में तो calculation, I don't think so you would need.
Sir,
Think
do
about
we draw a line, one from the a vertical line and opposite line, and where they meet is the resultant force?
state the resultant force magnitude.
Oh, magnitude.
The drawing, you won't need the drawing. You don't use the scale drawings unless they have told you that the diagram is made to scale. They haven't told you that, so you can't use the length and the length of these arrows and everything unless they have told you that the diagram is scaled properly, drawn according to scale. Nuba, Nadia, anyone? It would be 12. The resultant force of the F and 10 Newton would be 12 Newton, but in the opposite direction. The resultant force of these two would be over here, like this, and it would be the same as that 12, and the degree would be, angle would be 30 Newton, or 30 Newton कह रहा हूँ, 30 degrees clockwise from the positive x-axis. Why? Anyone? No one? It is because when you had all three forces, the sum of the forces was 0. So if you would remove this, so you would have the resultant over here. Why? Because when you would have this force again back again, this 12 Newton would be cancelling out this resultant force of 12 Newton over here because of these two, and then the resultant would be 0. Do you get it? Nadia, Nuba, Murtaza?
Yes.
Suppose that, okay, anyone else if he or she has a question. Murtaza, what about you?
Sir, can you explain again?
Look, the result, we know that when these three forces are interacting together, resultant force is 0. Okay, so now if I remove this, the resultant force would be in exactly the same direction as the one which I have removed, because of these two things, the resultant would be at over here 12 Newton. This would be the resultant, and now if I add that 12 degrees, the 12 Newton again back, this 12 Newton would be cancelling out this 12 Newton from here, and again the resultant would become 0. So the force that is being removed, this is actually helping us to make the system come at equilibrium. So because of this, So this 12 Newton force would be cancelling out the 12 Newton force in the opposite direction. If I remove this, समझ आया अब Murtaza?
Okay, yeah, I got it.
Nadia
Yeah, sir, I got it.
और कौन था? Nuba, all good?
Yes, I got it.
Otherwise, you could have done the good. Otherwise, you could have done the calculation and found that also. But this is state. State means that this is your logic. This is your understanding the concept. Okay, this was why I took this question out. Okay, now let's find a very recent past paper question. These are some old ones. Sorry, not over here. Forces and equilibrium, the first topic. Let's do a very recent one. Question number over here. Find the magnitude resultant force. Okay, this is easy. Look, question number 2 is also the same way. Exactly same thing. You would form two equations in the horizontal and vertical and then solve them simultaneously. Let's see if we have something different. Tensions. Okay, this is this is something good. This is also a good concept to be discussed. Now in this one, they have given you sine alpha is equals to 3 upon 5. They have not given you the value of alpha, the value of the angle. They have given you the exact value for the sine of alpha, which is 3 upon 5. So what can you do is, you can find alpha. One of the ways is you can simply find alpha by doing the sine inverse of 3 upon 5, and then you can work your way around that value of the angle. One more way is that they have given you sine alpha, and using this sine alpha value, we can find cos alpha value as well. Because sine, cos, and tan, we know that they all relate to a right angle triangle. So if this is alpha, so the value of opposite and hypotenuse is given to us. Opposite is 3 and hypotenuse is 5. And when you use the Pythagoras theorem, you will get this adjacent as well, which would be equal to 4. So now if I use the same cos alpha, if I find cos alpha, that would be equal to 4 upon 5. So instead of using this alpha as the angle, which would be in, you would have to take it in rounded off value. You now take the exact values. Now you break it down the usual way, the very same way. You break down the horizontal and the vertical component. This one would be P, and this is the component adjacent to this theta. So this would be cos theta. And this would be P sine theta. This force and this force. This one would be 24 sine alpha. This would be 24 cos alpha. This would be 36 sine alpha. This would be 36 cos alpha. So now you form the equations in the horizontal. Vertically, you have two angles. Sorry, vertically upwards you have two forces, which is P cos theta plus 24 cos alpha. This angle, this force and this force, and downwards you have 36 sine alpha. Now you know the value of cos alpha and sine alpha, exact values. Look over here, 3 upon 5 and 4 upon 5. So 24 multiplied by 4 upon 5, 36 multiplied by 3 upon 5. So you will get the value of P cos theta. It would be 36 multiplied by 3 upon 5 minus 24 multiplied by 4 upon 5, 12 upon 5. Now the same thing you will do for horizontal forces. So horizontal forces to the right side, you just have one, which is P sine theta. And left side you have 36 sine alpha and 24 sine alpha. So you would add them up. 36 sine alpha is 3/5 plus ये भी sine alpha 3/5. Wait a minute, I think I'm making a mistake. Look. The formula over here. It would be 24 sine alpha. Look, the upward forces. Cos alpha ही है. सही maybe. Okay, this one I made a mistake over here. This is 36 cos alpha. Vertically downward is 36 cos alpha. Look, sorry, my bad. This is cos alpha, which is 4/5, and we'll calculate it again. And this is also sine alpha. Now it's good, I think. 24 sine alpha, 36 sine alpha. Yes, now it's good. So 36 times 4/5. Yes, this is for 9.6. And over here you will get P sine theta is equals to 36 multiplied by 3/5 plus 24 multiplied by 3/5. 36. Now you divide both of the equations again. क्या गलती कर रहा हूँ? I'm messing up with the cos and sine again and again. Sorry. So you take the first equation, P sine theta is equal to 36, divide by the second equation, P cos theta upon 9.6. Now the P and P would cancel out, and tan theta is equals to 36 divided by 9.6, 3.75. So theta comes out to be tan inverse of 3.75, 75.1 degree. And now your P would be equal to P cos 75.1 is equals to 9.6. 9.6 divided by cos of the same angle, which is 37.3. Okay, all good?
Yes, sir.
So this is something new. This is I wanted to discuss this thing. To keep the things in exact form. Sometimes you will see this would help you out in other topics as well of the M1. Because sometimes the equation becomes so complicated. There are so many things to properly write it down. It's better to keep it in exact form. You will see them later on. The question won't be difficult, but it would have a lot of information to be handled all at once. So that's why when you work with exact values, it keeps your working short, concise, and more understandable. You work with the things very smoothly. You will understand it later, one way or the other. So there's this technique of finding sine alpha using cos alpha, or cos alpha using sine alpha, using this trigonometry simple Pythagoras theorem. This is helpful for M1, Edexcel M1. This is also a good one. The verb is W attached to 2. Okay, the other string for the equilibrium. Find in terms of W the tension in AC and BC. Now this is a very important question. You'll understand a lot of things over here. More things about this M1 which are important in other topics as well. So a very good question. Let's do it separately. First of all, there are right now talking about the weight of a particle. Okay, so what do? The weight of the particle, W is attached at C So weight is always acting downward. This is one thing that you need to always remember. Weight would be always vertically downward. Even if they don't tell you, weight is always, we know that, always downward. So even if they don't tell you, this is something that you need to deduce, infer yourself. Okay, so weight is downward. To two light inextensible strings, these are the inextensible strings. These are separate. This is one of them, and this is one of them. One of the other. So AB and AC and BC. The other ends of the strings are attached. The fixed points. These are fixed points A and B. Okay, and both of this is string one. Let's suppose this is string AC, and this is string BC. The particle hangs in equilibrium. There's also an important information over here. With the strings in a vertical plane and with AC, BC inclined to the horizontal at 30 degree, okay, and 45 degree, okay, everything's good. Fine. In terms of W, the tension in AC and the tension in BC. First of all, we can apply over here all of the angle properties that we have learned in IGCSEs, O levels, Edexcel, wherever that you have learned. So this is forming a Z angle. This is a parallel line. This and this are parallel. So if this is 45, this would also be equal to 45. So this is another thing that we now know. And definitely this would be 30 degrees. Okay. And about the force tension. Tension is a force always in strings. Tension, force is force in a string, rope, or any other wire. The force called in the string, rope, or wire is called tension. Okay, and let's suppose this is a rope. Okay, and it is hung from a ceiling. And there is a mass attached over here of, let's suppose, 5 Newton. So this means that there is a, and this is in equilibrium right now, equilibrium. So there would be a force of tension that would be opposing this 5 Newton force of the weight which is acting downwards. So definitely there would be a tension in this string which would be upwards, moving upwards, and that would be the same as this 5 Newton because the system is in equilibrium. So the tension in the string is simple 5 Newton. So the string is pulling this block of 5 Newton upwards, and the weight of the block is pulling it downwards with again the same 5 Newton. So both of these are in equilibrium. But the problem is that the other end where this string is attached, the string is going to pull that attached point downwards with the same force, 5 Newton. But there would be a resultant normal force on the ceiling which would be upwards, which is 5 Newton. The important thing is this thing, that the tension force is pulling something from one end and pushing something from the other end. This is an important thing. Over here, if I take this section, the tension is pulling the 5 Newton upwards. But over here, because of this 5 Newton force, this 5 Newton force is pulling the ceiling down. So this thing is important. The tension is acting on both directions. It depends on the position where it is being, what do we say, taken. Okay, this is an important thing. So now we can see that the weight is actually pulling it down. So there would be a force of tension over here. That is, it would be pulling it upwards, and there would be a force of tension over here. And at the ceiling, the tension would be pulling the rope downwards like this. So these arrows, when you understand this thing, you'll do enough practice, you will get a better hold of this thing. It's an important thing. So we now know the directions of the tension as well. This is over here like this. and like this. And now we can form the, so let's call this as tension BC and this is tension AC. The tension in the rope or the string AC and the tension in the string BC. One more thing about tension before we complete that question. Tension in the same string would be constant, because this is something important, because right now there were two strings. There was a string separately attached from this point to this point. This was a separate string and this was a separate string. They have told us, look, two light inextensible string. So the strings were separate. This is another one, this is another one. Okay, so when you have two separate strings, then the tension can be different as well. But when you have the same string, you will see something like this. For example, there is a ring like this, and there is a same string which is passing through the ring and going downwards and pulling it down. So in this case, the tension over here, pulling it down on both sides, it would be the same thing, same tension, because the string is same. It is the constant string. Sometimes on a pulley as well, when you have a pulley, we'll do this pulley thing later as well. It would be done in more detail. Pulley में भी क्या होता है? A string is being wounded around this pulley like this, and it goes down. So the string is same. So the force of tension over here and then over here, it would be the same because it's the same string. Right now, because the strings were different, we would have different tensions in both strings. And now we want to find the tension in string AC and BC in terms of W. So what do? They have told us this is an equilibrium. So sum of vertical force would be 0. So vertically we have, if we break it down into components, this would be tension BC cos 45, and vertically upward this would be tension BC sin 45. This would be tension AC cos 30. This would be tension AC sin 30. So what is it? This would become vertically upward, you have tension BC sin 45 plus tension AC sin 30 is equals to, downwards you have W, and for the horizontal ones your equation would become tension AC cos 30 is equals to tension BC cos 45. That's it. There is no component of weight in the horizontal direction. Now we need to find tension AC and BC in terms of W. So we have to solve them simultaneously, right? So if you simplify the first equation, this would become root 2 over 2 tension BC plus 1 over 2 tension AC is equals to W. And this would become root 3 over 2 tension AC is equals to cos 45 is root 2 over 2 tension BC. What can we do? What can we do? If we make this TAC subject over here, it would become root 2 over 2 multiplied by 2 over root 3 TBC. And now this 2 and 2 would cancel out. Root 2 over root 3 TBC. So TAC can now be replaced with this thing over here. So root 2 over 2 TBC plus root 2 over root 3 TBC is equals to W. So if we take the TBC common, root 2 over 2, root 2 over 2, use your calculator, plus root 2 over root 3. An exact form this is giving you. They are asking you in exact form, find in terms of W. It's better to keep it in exact form, otherwise it's okay if you give it in this points as well. So TBC, and if we take the LCM, they haven't given us the LCM thing. Okay, so this is TBC 1.524 is equals to W. So TBC now we know it is equals to W over 1.524. This is your first answer. TBC in terms of W. And now you will substitute this thing again over here, right? So TAC would be equal to root 2 over root 3 and multiply by W over 1.524. This would give you your TAC. Do you get it? समझ आया? This was a good question. Murtaza, Nuba, Nadia.
Yes, sir.
So the things about the tension which I told you, these are very important things. Note this down and focus on this whenever you see a question like this. Take a screenshot. Ask if you have any questions. Nuba, all good? Nuba? Nadia?
Yes, sir.
Yes, sir, it's fine.
The only difficult part over here was the simplification. Otherwise, the concept, the equation forming, that was the same thing. Okay, take a screenshot. I'm ending the class now. The topic is over now. We'll have another class, tomorrow's class. We'll do more past paper questions for this thing. Okay, stopping the class recording.